If we square any odd number and subtract 1, what is the largest common factor? Try 3, 5 and 7. Squaring and subtracting 1 gives us 8, 24 and 48. So this case suggests that 8 is the largest common factor. But can we prove this for every odd integer? So let us formalize this question. What is the greatest positive integer d such that n squared minus 1 is divisible by this d for every odd integer n? The options are 2, 4, 6, 8 and 16. TMUA requires ability to conjecture from cases. Take the first few values here. For n equal 1, 3, 5 and 7, the results are 0, 8, 24 and 48. These cases support the conjecture that d equals 8, but a conjecture is not a proof. Now we can construct direct deductive proof, so this comes under PRF1 on the TMUA specification. Factor the general expression n squared minus 1 as n minus 1 times n plus 1. Because n is odd, the numbers immediately below and above it are both even. So n minus 1 supplies a factor of 2 and n plus 1 supplies another factor of 2. Look at the even numbers. 2 and 4 around 3, 6 and 8 around 7, and 10 and 12 around 11. Every other one is a multiple of 4. So any adjacent pair of even numbers contains a multiple of 4. So this supplies us one more factor of 2 from the other two above. Because n is odd, the numbers immediately below and above it are both even. So n minus 1 supplies a factor of 2 and n plus 1 supplies another factor of 2. Every other one is a multiple of 4. So any adjacent pair of even numbers contains a multiple of 4. So this supplies us one more factor of 2 from the other two above. Together, the product contains 2 times 2 times 2, which is 8. So 8 divides n squared minus 1 for every odd integer n. And we could do the same process for negative integers as well, because we would get two negatives times together, which would give us a positive integer. So what about n equals 1? This gives us 0. And 0 is divisible by every positive integer d, because 0 equals d times 0. So n equals 1 places no restrictions on d. After 0 at n equals 1, n equals 3 gives the smallest non-zero value of n squared minus 1, which is just 8. This is the smallest non-zero outcome of n squared minus 1. Given d must divide for all at n, it must divide for this n equals 3, so the largest common divisor to them all is 8. This follows the TMUA proof structure. Use cases to make a conjecture. Prove the general rule by direct deduction, then handle the edge case and show the result is the greatest possible. In the real exam, you would not necessarily need to construct this full deductive proof, especially if time's running out. Just go with the outcome from the casework. So if you like this content, please follow and share. The first 100 would get premium access to every TMUA in the question bank I'm curating. So I'm Dr. Nicky Grant, with 3 Cambridge economics degrees and extensive experience supporting TMUA students.